All right, so hello everyone. I'm Caleb, and I'm about to be presenting on process ghosting for Windows and evading antivirus detection. So, first of all, who's this handsome devil up here? That is me. I'm Caleb. You probably know me. I'm a second-year CSEC student. I like birds. I'm from Northwestern Pennsylvania, and I'm also an apprentice with Windows expert. So, yeah. All right, so a quick introduction. So why did I choose this subject? So while I was at the old ShmooCon, I went to a very interesting talk about Windows, and the presenter briefly mentioned in the slides about something called process ghosting, and my interest at this point was pretty piqued. I mean, I didn't know what process ghosting was. It sounded interesting, so I did some research, and I decided to do a little bit of it on my own. So this talk will quickly cover the basics of process creation in Windows, how and when antivirus software scans for malware on Windows, or I guess anywhere, but focus on Windows, and how to evade detection using process ghosting. So, how's a process created on Windows? Firstly, you have a handle to an executable. You open that using something like create file, and then after that, you make an image section from the executable file. This section maps to a portion of the file in memory, and this essentially maps it from the executable file into memory, and then that will later be used to create a process. So the process is now created from the image section, and you can use something like nt create process for this. Important thing to note here, the process is created, but it is not yet started. It's just a process. It's just basically sitting there and not doing anything. You have to actually assign a thread to it first. Before you assign the thread to it, though, you have to do the process variables and environment variables and assign those to the process for it to run. That's things like environment variables. The process knows what to look for and any sort of like parameters it needs in order to run. You got to assign those first, and then you can create the thread, and that will actually execute the program. So this is how it looks like in Process Monitor. You can see here we've got a create file, and then it maps that file into memory. It creates a process, starts the process with the thread, and yeah. So you can kind of see it, the whole process there, opening up Notepad from Explorer, and so yeah. So now we go to antiviruses and when they scan for malware. So antiviruses have to make a decision on when and how often they scan. Ideally, this would be after every modification for a file, but in reality, that's very much impossible because it would require an absolutely absurd amount of computing power and memory to do so. So instead, they kind of make a compromise, and instead they just limit themselves to scanning only when certain events happen, such as when a file handle is closed, because that's a very good indicator that, okay, we're done modifying this file for now, and we can scan it and not have to like continuously update every time a single byte is changed. They also can have API functions such as this PS set create process notify routine X. Thank you, Microsoft, for these very helpful naming schemes and very succinct. So you can call these API functions to be notified when an event occurs, and so we'll go into a little more detail about this particular API function here. So this is a bit of a misnomer because it doesn't notify things when a process is created. It notifies them when the first thread for that process is created. So it returns this little thing called a PS create notify infrastructure when the thread is created, and that will be more info on the next slide for that. But this basically allows antivirus software to intercept and scan the executable before the process actually begins to run. So when a process is created, this event will occur. The system will basically send it out to all the antivirus or any other driver software that's interested in seeing when a new process is being created, and then they can use that structure to find the original executable file, scan it, check it out, make sure it looks good, and yeah. So we have this little flow chart here of the general process of how a process is created. It goes from file to image to process, and then we add a thread. And you can see when that thread gets added, that is when this event occurs. So it returns this little structure here called a PS create notify info, and it contains a bunch of stuff, but the main thing of importance here is this file object structure, which corresponds to the basic handle of an executable file, which can be scanned and see if it's malicious or not. So now we get the process ghosting. So what if we were to tamper with the file before creating this process? We could potentially create a ghost process by deleting the file. If there's nothing to scan, then there's nothing for the antivirus to report. At least that's how it sees it personally. I would consider if you look at a file and it doesn't exist anymore, it's kind of a little suspicious, but I guess that's not how they see it, at least. So yeah, we create this little ghost here, and then there's nothing for them to find. But there is an issue with this. So creating a process is usually done by API calls like create process, or syscalls like nt create user process. The kernel does most of these work in these functions, so it prevents file modification from happening, it creates the image section, it returns the process, and then the process is scanned all before we even have access to modify it again. So by the time we are able to even modify that file, it's basically already been scanned and checked for malware, and yeah, it's not very good. But luckily, there are other ways to create process. And that's when we get to the super scary and not fun legacy functions. So, deep in the heart of Windows, there exist scary undocumented functions that come from a time before time, aka pre-Vista. And these are examples of just things such as nt create process x and nt create thread x. These legacy functions allow us to take much of that process creation steps out of the kernel and back into user mode, which means we can modify files to our heart's desire before we actually create the process. And these are really annoying to work with because, as their name may imply, they are undocumented. And so there is very little documentation out there for them. The only things we really do know about these is thanks to some very smart and helpful reverse engineers. Shout out to undocumented.ntinternals.net. A very helpful website for this kind of stuff. And also the classic random Chinese/Russian blog sites that have this stuff on there for some reason. So yeah, that's the Windows experience really that I've been learning and experiencing the past few days here. So we're going to go through the quick workflow of how this actually works in more detail. So first we use create file and write file to write some malware to the system. And then after that, we're going to mark it for deletion. We use that with set file information by handle. And so now when this handle gets close to the file, it will be deleted. And also of note is that when we have this file marked for deletion, nothing else can open it. So even if antivirus happened to be scanning the system at the time, they couldn't open the file to actually scan it because it's set for deletion. So as far as the system's concerned, once we close that handle, this thing is gone. Now we create the image section from the malicious file because we still have the handle open, so we can create an image section from it. And we do that, and it's in memory now. So we have the image in memory using nt create section. Then we can close the handle file, which now deletes the file. And so we have a ghost file, or I guess there isn't really anything there anymore, but let's just, for learning purposes, let's pretend there's a file there that is no longer existing. It's a ghost. And meanwhile, we still have the image in memory, even though the original file that the image came from no longer exists. With that image section memory, we can create a process. This is where we also write the process environment block. I'm not going to go too much detail about that because, to be completely honest, I don't really understand it that much, and it's very complicated. Yeah, it was by far the hardest part of this entire thing, and I actually had to use someone else's code for that because I could not get it to work. It was a bit of a mess, but we use nt create process x, and then we'll go a little bit into like the process environment stuff when I go over the demo. But once again, I don't want to dwell too much on it here. So now we can create the thread to assign to the process using nt create thread x, and then at this point, the ps create notify x routine alerts any antivirus software on the system that a new process has been run. So now this antivirus software can get the handle back to the original file, which is now the ghost file, and it will give it a scan. But it's not going to find anything there because there's nothing there. And for some reason, it decides it checks out and allows it to proceed. So the antivirus never actually scans the process in memory, so it never actually scans like the actual malicious stuff going on here. It just scans the original file that correlates to it. But since that file no longer exists, it has nothing to scan, and so once again decides that it's not malicious and it's fine to run. Now it's demo time. So this is really exciting. So let me go back to my Windows machine here, and let's take a quick look at the code here. This is also very, very awful. I'm not gonna lie, I have to clean this up still. I was working on this very late last night and still have not cleaned up some stuff. So This is going to look very confusing. I'll try my best to walk everyone through it. So we have a bunch of undocumented functions here that we're importing and defining so that we can get them using get proc address and import them from the library. So we'll just quickly go down here. I also added a quick export encryption decryption method here. You'll see why in a minute when I go to the actual demo, but they're not too important right now. Basically, we can just encrypt a file, and then this will encrypt it and write it to a different file. And you'll see why again in a moment. So first, we take a file path, and then it decides whether we want to encrypt it or decrypt it. Basically, in this program, encrypting just encrypts a file, and decrypting decrypts that file and runs the actual process ghosting workflow. So we first create the file that we're going to be ghosting. I call it ghoste.exe, and then we assign all the fancy little parameters to it so that it can run. And there is a flag here you can set for it to be deleted after you close it. However, this is a little misleading because it doesn't actually work. It doesn't delete the file as intended, so it doesn't work for this demonstration. You have to explicitly use the set file information by handle. So before we do that, though, we copy payload from the source to the temporary executable file, and I do that in this decrypt and write method, which will take the encrypted file, decrypt it, and then as it's decrypting it, it will write it to a new file and return that file. So now we go to set file information by handle, and this is going to take this file, disposition info, little variable here, and this we set delete file to true, and we give that to set file information by handle. That's essentially going to tell it, okay, delete this file after the handle closes. Next is creating the image section. This is where we start to get into some of the less documented stuff, some of the more legacy functions. But yeah, we're going to add the import ntcreate section here, and then we're going to use that to create the image section in memory. And you also can see here, I started out originally like documenting things like fairly well, and then I started to get deeper into this and started just slowly going more insane and stopped documenting anything. So this is where it gets a little more confusing. But after we create the image section, we now can close the handle of the file. We no longer need it, and that will delete the file. And now we have this image section in memory still, so we can use ntcreate process x in order to create this process. We give it all the information it needs to create that process. And once again, because we're using these legacy functions, we have to take a lot more of the stuff into our hands and actually explicitly add certain things. So it gets a little annoying at some points because like you have to basically create the process by hand, which is one of the drawbacks of bringing everything back into user mode. So this is the part I had a lot of trouble with. This is assigning the process environments and like the process environment block for the child process. I had a lot of trouble getting this to work, and I do want to like try and figure it out my own at some point. But for the purpose of the demo, I had to use some existing code for someone else's process ghosting thing, which has been very helpful here. If you scroll up, this is where all the functions come into, and this stuff gets very scary. So avert your eyes if you're not ready for this. There's a lot of just stuff here I don't really quite understand. We have to get like the entry point of the process. We have to update all this process environment stuff. We have to create the block and write it to the process. It's a lot of scary stuff. And once again, I don't want to go too much in here because I don't really understand it, to be honest. So that creates the process environment block and basically configures the process to be ready to run. And now we can go ahead and use ntcreate thread x in order to create the thread and give it the entry point of the process, and then it will run. So yeah, that's the overview of the little program here. And now we can do an actual demo. So let me resume this VM. All right, so now we're here. And so we'll start off. I have Defender on currently. We have Process Explorer open, and then we have some files here in the C directory that I will be using for demonstration purposes. We're going to start off with diskview64.exe. This is just a random sysinternals exe. No, not a harmful file whatsoever. We're just going to use it for test purposes to show how this works. So first, we're going to use the ghoster exe, and we're going to give it the file path of oh gosh, it's gonna be hard to type with one hand. C, and then disk view 64.exe. And we're going to encrypt that first. So now the file's been successfully encrypted, and we're given this encrypted file, which is the disk view 64.exe.enc. And now we can take that file and we can decrypt it and run it. And so now we have disk view. So it runs, but there is something that's peculiar about this process here, and that is we're going to be able to see it in Process Explorer. So we target this window here, and you'll see this process is not disk view, it's system idle process, which is odd. We go to properties, and you can see that the path says access is denied because there's no path to be found. There is no parent ID for this process. It's basically just this strange little orphan process that no one knows where it came from. So we can do something a little more malicious now. We can take a malware sample such as Mimikatz, which, if you don't know what Mimikatz is, it's a very well-known credential stealing tool for Windows. What?
Post-exploitation.
Post-exploitation, for sure. But I chose it because it's, for one, easy to get, and two, I know Defender is going to immediately target that. So once again, I have the zip file here with it, and as soon as I extract this, Defender is immediately going to start complaining that there's malware on the system, and yeah, you know how it is. Yeah, see, threats found. Oh no. And we go, oh no, Mimikatz. Okay, I don't know why it's doing that. It's a lot of malware there, but so yeah, it found Mimikatz. It doesn't like that. So just show you kind of what happens. So right now it's already quarantined it and like basically deleted it. So can't even use Mimikatz right now. But let me turn Defender off real quick, and then try that again. So we can just at least get the executable out without Defender immediately trying to kill it. So now we can go back into here. We have the executable file. And so now I should be able to turn it back on and at least run it without Defender trying to kill it. And it's going to immediately find out that it's malicious. Oh no, malicious file. Don't care, run anyway. And it's still going to say operation not complete successfully because the file contains a virus potentially unwanted software. So Defender is saying that, hey, this is bad. We're not going to let you run it. This is what happens when you try to run the file, and you get it gets the create notify function and intercepts it before you can really do anything. So now it's taken that and taken off to some dark place where who knows what Defender does at this point, but it's gone for our purposes. So before I did this demo, I created an encrypted copy of Mimikatz. This is why we need an encrypted thing, so I can have my payloads on the system without Defender immediately trying to kill them. So I did a basic XOR encryption, basically hide it from Defender, so we can decrypt it and write it to the ghost file without ever actually touching the disk, so no antivirus can like just scan it and delete it before we can use it. There's other options you can do as well. You could always take it through network, for example, and decrypt it through there. You could also try to just hard code it into the process and into the program and have it right from that. But I think the easiest way for me, at least, was just to have it on the system as well. So there it is. It's Mimikatz encrypted, and I'm not going to re-encrypt it because it's an annoying pain to do that. But as you can still see, Defender is still on now, so ideally it would find Mimikatz and see, oh no, that's bad, and stop it. But we'll see what happens here. So we go back into mimikatz.exe.enc, and we're going to decrypt that. And it runs. And once again, you can see here that if you target Mimikatz process, it's once again the system idle process properties. There's no path, no auto sort location, and Defender is sitting here twiddling its thumbs because it has no idea what's happening. And we can even, once again, it's not just like a basic like startup thing. If you start doing malicious things as well, like if I run a command to Mimikatz, such as if you roll say and then log on, oops, messed that up. Log on passwords. It's going to give us the clear text passwords of all the users in the system, which is currently just Bingus. And I don't know if any of you can guess what Bingus's password is, but but yeah, so it gives you all the passwords here. And once again, it's doing most of the stuff now. It's leaking passwords, and still Defender has no idea what's going on. So we've successfully evaded the antivirus, and it has no clue what's happening here. So we can close out of it, and nothing will be found. So that's about it for the demo, and then we'll go back to the slides here. I have one more slide here, the questions slide. Shout out to Mr. Enzo for helping me figure out all the scary documented functions. He's been a lifesaver during this. I love you, Enzo. Anyway, anyone have any questions?
I feel like a proud parent right now, Caleb.
Love you, Kenny. Hello, Zach.
How can this be used offensively?
Oh, let me tell you something.
How can this be used offensively? I don't know. I'm struggling to think of any application this can be used offensively, personally. Yes?
What about defensive?
Defensively, oh boy. Now, let me tell you.
All right, I'm picturing right now.
Picture this. Say you want to hide your defensive tool from malware, right? Ghost that.
Oh, okay.
Easy as that.
That makes sense.
Yeah. Offensively, no way. Can't do that, but. Right.
Caleb.
Yeah.
Oh, buddy, we're about to be devious.
Oh, yeah, we're being devious. All right. Diabolical, even.
So picture this. We take Z for
I did miss the beginning. How?
Yes.
What got you into this?
Yeah, so originally I went to a talk at SmooCon about Windows, and I try to remember what the talk was originally about. I think it was about how like hiding processes and stuff on Windows, but there was a brief mention of process ghosting, and there wasn't really an explanation of what process ghosting was. It just kind of briefly mentioned it in the slide notes. I was like, that sounds interesting. What is that? And so I did a little bit of research, and it sounded pretty interesting. I started reading into it, and so that's what kind of got me into this. And I thought, hey, this would be a fun thing to try and do. I'm happy I did it. It was fun, but last night I was struggling. I was fighting some Windows. Yeah.
How much like time and effort, or yeah, I guess how much time and effort did it take to like kind of figure this all out and get the demo working?
So for me at least, I've never really gone much into like the advanced Windows stuff like this. This is my first time doing it, so it definitely took me a little more time to do it. There was a lot of like resources online for this kind of stuff already. One very helpful website was Elastic, which I think did the original like write up for this and report it to Windows. And by the way, if you're curious, Microsoft's response to this was like, we realize this is an issue, but it does not fit our criteria for immediate like fixing. So it still works. And I think Microsoft has released a thing for Defender Endpoint, which can detect this sort of stuff, but actual Defender still hasn't caught on yet. And there is a way to detect this stuff, which is very advanced, and you have to do some very weird things to do that. So it's fairly stealthy overall. But what was the original question again?
I guess how much time and effort?
Time effort, yeah. So yeah, I started this a couple weeks ago and have been working on it kind of on and off. But yeah, the main part I think is trying to decipher what all these functions mean. Microsoft documentation is really good for things that are actually documented. But when it comes to things that aren't documented, like half these functions I'm using, you have to do some weird thing. Like if I can go to the NT internals website right now, here, you can see the site here has been very useful for me in terms of like NT create section, for example. This is in the NTDLL library, and it's undocumented, but this one allows me to see like what the different parameters are so that I can create a type for it and import it and then throw all that stuff in there and run it. If you're in the club room a few days ago, you probably heard me complaining about how I had to go to archive.org and look at a forum post from 20 years ago to get this information about one parameter in this undocumented function. That's like the Windows experience right there, is trying to dig down, and when you're working with the undocumented functions, it gets really annoying because once again, they're undocumented. You have no idea what anything means and what's necessary or not. And that's the biggest pain, I think. And I'm still not technically done with it. I still want to work out and figure out the process environment stuff on my own. I also want to clean up the program a little bit. But for the most part, I mean, it works. It's able to do what it's supposed to. And I'm happy with it. But yeah, I don't have an accurate number for how long this took, but it definitely takes some effort and it takes a bit of time. But I think once you start to get used to this stuff, it becomes much easier because you're much more familiar with like the undocumented functions and kind of how they work. Any other question?
Can you kill that ghost process?
Can I kill the ghost process? Yeah, I believe so. So if we like, what do you mean kill it? Just like
Yeah, like can you see it in Task Manager and kill it?
oh yeah, I think Task Manager shows that. I think you can kill it as well. So let me try something like let's just do Mimikatz again.
True. A little Z4I.
Yeah, so let's Task Manager, just do a quick Control Delete. So Task Manager is even less aware of this than like Process Explorer is. It just literally shows this blank process. So it's not really much detail on what that is. You can see Mimikatz down there at least, but like again, the parent process is just this blank thing, which I think you can still kill it fine. Like it still deletes fine. And it's just in terms of finding out where it came from, that's the difficult part.
Can you give it can you make it appear as something not blank in Task Manager? Because that's kind of sketchy.
Yeah, I think you can. So I think if we go back to the not that one, but go back to the program, Visual Studio. If we go to this is where the process environment stuff comes into. While I was messing around with it, there is this process environment block where if I can find where it's defined at, I think set of process parameters here. Yeah. So you can see different things here. You can see things like the image path name, DLL path, command line. This all shows up in Process Explorer. Currently, they're all blank for some reason. I think they were working before, but it's just supposed to show the directory of the process ghosting exe. But if I go back and just create another one real quick, oops, and then go back to this and find it. So that's where all these things come into when you go to properties and see like command line and path and stuff like that. So if you can, I think if you configure the process environment block correctly, you can basically customize those to your choosing. And that I think that includes like the process name as well. So you can definitely disguise it as whatever you want. And I think there's also ways, because the original talk I got this idea from was talking about how you can hide processes from things like, Task Manager entirely, so it doesn't even show up in the first place. So that's a little extra stealthy, but yeah. Kenny.
Hypothetically, how would you want to expand on this? Because this is just a proof of concept, right? But I know you could do some quirky little things with, you pull it down from a web server and then you decrypt it, run it, delete the encrypted version from disk, and now that's in memory. Would you want to go that route, or would you want to, do some other quirky stuff?
Yeah, so the question was how I want to kind of expand on this, and I think that's an idea I had was kind of incorporate networking into this, so you can like pull kind of like a C2 almost, like you can kind of just pull whatever payload you want over the network, so that way the payload doesn't have to exist on disk where someone could find it and delete it. So you could definitely do that, have networking to send the encrypted file basically over networking, decrypt it in memory, and then write it to the ghost file and do that. And yeah, I mean, I also want to incorporate some persistence in this somehow, because currently, like Drew kind of pointed out, you can just kill the process and it's done. But like,
Don't worry about that.
Oh yeah, don't worry
That'll
about
get handled.
Yeah, I think it's a fairly easy workaround. I haven't like dug much into that part yet, but it's kind of just the tool itself. There's also a few other things that I kind of want to mess with that are similar to this that also use these transient file states. There's a thing called process doppelganging, which is a similar thing where you use the Windows NTFS transactions to like basically write to a file and then undo the transaction so that you can create the process when you write to it, but then when you undo it, it rolls everything back so that the file looks like how it was before. There's also process herpaderping, which is the actual name for it, and that involves, it's a similar thing where you basically modify the file after you open the handle to it and create the process block, but instead of deleting it, you just kind of overwrite it to look like something not malicious. So you can basically have, for example, a disguised version of like some program, and then you modify it to make it malicious, and then create the process out of it, and it looks legit, and like everything else, it looks legit, but it does malicious stuff in the background, and then the actual file, if you inspect it, looks legitimate.
Yeah, swag, Caleb.
Yeah, swag indeed. Hello, Sherrod.
Can you go through like the functions you call, like and I guess the specific order, like in the functions that you
Repeat
call.
that.
Can you go through the order of the functions? Like,
Yeah.
to set it up. Because I'm just
Yeah,
gonna
so
internals,
yeah, oop, I don't know why this is.
I guess.
If this will let me, I think Parsec is screwing up right now. Try. Okay, there we go. So yeah, if we go back to Visual Studio, we have some early on. You have a bit of a choice what you want to do because like you're not really in like the deep part of Windows yet. We have to like start doing the legacy functions. Like right now, you can just do the create file, open file, whatever you want to use there. Mainly the things you are concerned about is these undocumented functions that I have defined here. So you have NT read virtual memory, NT query information process, which is used in the process environment block stuff. NT create section, NT create process, NT create threadx.
Those functions exist. Wait, no, never mind. I'm looking at the TNT.
Oh yeah,
That's the
type.
difference.
Yeah, that's
Yeah.
yeah. So the functions they do exist. They're in NTDLL. The issue
Yeah.
is I have to like that's like a kernel thing, and I have to like I think there's ways to like have those in Visual Studio to work with regularly.
Yeah.
But the way I was doing it, I had to like import them individually.
Okay.
Also, you'll notice that like we have this ntddk.h. This is one of the one of the people who did the first like process ghosting example on GitHub. They have this, which is basically a rewritten version of winternal.h, because there is a structure here when you use the RTL create process parameters, something like that. It uses this one structure, which is not well defined whatsoever in Windows. It has like there's a bunch of different parts to it, but the documentation only has like 4 of them mentioned, and half of it's just like, oh, this is reserved for internal use. So it's completely useless. So you have to rewrite it to basically include that in here, and that way you can use it in the actual thing. But was there any particular like?
I guess the thing that I was mainly concerned is when do you close the file?
Yeah, you close the file.
Close the file after you launch the process, or
You close it before you close it after you create the section before you launch the process. So you want to have it in a state where the process section, like the image section, is in memory, but the process itself has not been created yet. So you can close it after that. Now delete the file. Everything's gone. The image still exists in memory, and from that image, you can create the process.
that makes sense. Okay, thank you.
Yeah. Anything else? All right. Thank you, everyone, and hope you guys enjoyed. If you have any questions about this, feel free to contact me. What?
Go up to your imports real quick. Now you can end it.
Oh, my imports. Sure.
My friend Joe has everything. You have Joe.
Okay. Yeah, Kenny pointed out that I was missing an import Win32 lean and mean. Then yeah, that would make a lot of sense actually now, because that includes all the stuff that I've imported without having to like include everything else. So thank you, Kenny, for pointing that out, and that's one thing to improve on. So yeah, thank you, everyone, and have a good day.
It's internal.